Hi everyone, in this video I want to work through an example similar to the last one, but here we're going to be a little more general. So instead of giving you a specific x or y coordinate, I'm going to give you a variable to use as your x or y coordinate, and then we're going to try and find all of these a through f things here in terms of our variable. So, I see a cut and paste error already. This should be a w. Okay. I'm giving you the information that cosine of w equals p. So what you get for free is that your x coordinate is p, and that's not a lot to go on in terms of where you are on the unit circle, but it is narrowed down to a single quadrant. So w, the arc length, lands somewhere between pi and 3 pi over 2, which is going to be in quadrant 3. Okay, so we're somewhere in quadrant 3. Again, this is really important if you're working on a problem that involves trying to spot some symmetries and you have a choice. Do not put your point anywhere near one of the pi over 4s. It'll be really hard to see when you have flips across y equals x. So I don't really care in a problem like this where you don't know whether it's closer to x or y, which you choose, but you should definitely choose to be closer to an axis and not closer to the middle. So I'm trying to think what our last one looked like. Hold on, I'm going to peek so that we can make it look different. Our last one. Okay, so it was closer to an x-axis, so let's make it closer to the y-axis. Okay, so this is going to be my original point. It's at the end of an arc length w, so w goes from 1, 0 all the way around to here. And we know its x-coordinate is p, and that's all we've got to start with. So first thing we're supposed to do is find sine of w. So we're at this location, end of arc length w. We're looking for our y coordinate. That's going to be a Pythagorean theorem. So we can say x squared, except that we know that our x coordinate is p, plus y squared equals 1, which means y squared is equal to 1 minus p squared. And again, you want to think about this as pretend I'm giving you a value for p, and then we want everything else in terms of that. So y is going to be plus or minus the square root of 1 minus p squared. Because we're in quadrant 3, we want a negative y, so we'll choose the negative square root 1 minus p squared. Okay, so here's our point, and something really important to notice, and it can be a little bit confusing as we go through, but I did that deliberately so you can see what to watch out for. It's not a mistake that I'm writing p and not minus p here. There's no rule that says variables only represent positive numbers, so you just want to remember as we go through here that p definitely represents a negative number. Okay, so sine of w is negative square root 1 minus p squared. Next, we would like to find the tangent of 2 pi minus w. Okay, so 2 pi minus w means we've gone all the way around and then we back up w. Okay, so w is not quite 1, 2, 3/4 of the way around. So all the way around minus 1, 2, not quite 3/4 of the way around puts us here. And again, it's fine to think about it that way, to think of what you did. You went 2 pi minus w, but really what that means is we should have figured out what 2 pi minus w was ahead of time, and that's our arc length. That's the 2 pi minus w. Okay, so this point ends up being directly across through the x-axis. So we cut straight across vertically, flip over the x-axis, and our x-coordinate stays exactly the same, but our y-coordinate should change signs. So now we want a positive root 1 minus p squared. Note the square root, unlike the p, is not ambiguous about its sign. A positive root is never going to give you a negative number, and a negative root is never going to give you a positive number. On the other hand, p can be positive or negative, which means the opposite of p could also be positive or negative. Okay, so we figured out where 2 pi minus w lands us. That's the first thing, figure out where you are. We've got the coordinates associated with that landing spot, and now we want to figure out the value of tangent. Tangent is sine over cosine, so we're going to get a square root of 1 minus p squared divided by a p. Okay, next we want to figure out cotangent of pi minus w. Okay, so pi puts me over here. And then if I go back W is not quite 1, 2, 3/4 of the way around. So I should land here. And again, you want to realize that there's some canceling out that happens. If you start by heading over this way and then you backtrack all the way around, these two just wipe each other out. The point would be to not do that in the first place, to figure out ahead of time that those wipe out, and that this right here is your arc length. So this is a pi minus W. The point we land on is directly across from the original point through the y-axis. So its coordinates are going to be the opposite of P. And again, I know this can get a little confusing, but you really want to train yourself not to look at P and always assume that's a positive number. So here P is definitely negative, which means the opposite of P is definitely positive. For example, if P is negative 1/5, then the opposite of P would become positive 1/5. The y-coordinate should stay exactly the same, so it still is a negative root. Okay, so there's my point. My cat is trying to bust in here. We are looking for cotangent. Cotangent is x over y. So we're going to get a negative, no, let me say it right, because that's what leads to a bunch of this confusion. We're going to get the opposite of p over the negative root of 1 minus p squared. It is okay to say negative root here because you really are making that a negative number. But here, you're taking a negative number and making it positive by finding its opposite. Okay, so opposite p over negative square root of 1 minus p squared. The negative signs are going to cancel out. So we are going to end up with a p over the square root of 1 minus p squared. This again, notice, even though now people would be inclined to say, oh, well, no, it's positive. It's not, because p is a negative number and the root is positive, or non-negative at least. Okay. Let's see. Secant of pi plus w. Pi plus w, this is all going the same direction. So if you want, that's one where I kind of like the opposite. So you could absolutely go pi and then say, I need to go another 1, 2, not quite 3/4 of the way around. Or you could say, here's w. I want to go an additional pi, which is halfway around the circle. And that would land you here. So pi plus w, there's no canceling out that happens. There's no subtraction. So it really is just all the way around. And then, oh, I'm sorry, halfway around, and then not quite 3/4 of the way around. And that's my w plus pi, or pi plus w. And it lands directly across from this point, directly across the y-axis from this point. So it's going to be an opposite p and a positive root 1 minus p squared. We're looking for secant. Secant is 1 over cosine, so it's going to be 1 over the opposite of p, or opposite of 1 over p is how I'll write that. Okay, 2 more. Let's see. Go back to green here. So if we want to go cosine of pi over 2 minus w, whenever the pi over 2's get involved, this is where you get the flips across y equals x. So if we want, pi over 2 minus w, w is not quite, let's see, 1, 2, 3/4 of the way around. So I'm going to end up just shy of there. You could also look at this as taking a minus w. Let's see, I got to remind myself what w even was. Okay, so w is this one. We could go the opposite of w. It would land us here. And then we need to add a pi over 2, which is a quarter rotation. So if we look at this triangle right here, for example, you could use others as well, but that one, we know that the y-coordinate is the square root of 1 minus p squared. And the x-coordinate is a p. So when we rotate the x-coordinate, we spin a quarter of the way around the circle, becomes our y-coordinate. This was a negative x-coordinate represented by p. This is a negative y-coordinate, so it will also just be a plain old p. P is a negative number. The square root of 1 minus y squared p squared, can't read my own little thing, rotates around and becomes the x side of this, so it's the square root of 1 minus p squared, except that it was a positive y value, it becomes a negative x value. So here's our little triangle sitting here, rotated a quarter of the way around. So this point is negative square root of 1 minus p squared p. We were looking for cosine, so that's just negative square root 1 minus p squared. And then very last one, secant of 3 pi over 2 plus w. And again, if you'd like, so you can think I went 1, 2, 3/4 of the way around. And then I want to go an additional w, which is not quite 3/4 of the way around. So 1, 2, not quite 3. So I think I should land here. Or if you prefer, you could switch the order and say, first I go w, which lands me down here, and then I need to go another 3 pi over 2. So here's 1, 2, 3 pi over 2. Either one should get you to the same place. And what we've done for either one is go more than one time around to land here. So it's all the same direction, no canceling. That arc length really is 3/4 of the way around and then almost 3/4 of the way around on top of that. So this one is directly across from the point I just found. So it's going to have x coordinate negative 1 minus p squared, negative square root of 1 minus p squared again. And then its y coordinate should be positive. So we actually want the opposite of p. Too bad my blue ones end up in the same quadrant. We were looking for cosecant, which is the reciprocal of sine. So it's 1 over negative p, 1 over the opposite of p, which is the same as opposite of 1 over p. All right, thanks for watching.